Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces the concept of data transformations. Let's get started. So, as we've seen, many data sets have a normal distribution, but there are also many data sets that do not have a normal distribution. So, the quantity of tools that we have in our tool bag for working with normal distributions, we can't use those tools unless the data has a normal distribution. Well, how do we get around this? That brings us to the idea of data transformations. If we can take our distribution and perform a mathematical operation on each of the values in the data set such that the resulting transformed data set has a normal distribution, then we can use that bag of tricks that we have in our statistics toolbox to analyze and interpret these data. So, common transformation that we typically make is to use logarithms. So, we're going to replace each value of x in our data set with the value of log of x plus 1. This is a very common distribution data transformation that's made. So if this results in a normal distribution, then what we have is what's called a log normal distribution. So called because the distribution is made normal by applying a logarithm to each of the different values in the original data set. There are all host of different transformations that we can make. So we could take the square root of each of the values in our data set. We could take the reciprocal. We could square each term. We can add, subtract, multiply, divide. So any sort of mathematical operation that we can perform to a number, we can use as the basis for transforming our data set. To illustrate more of what we're talking about with data transformations, let's look at this example data set that we have here on the screen. So I've got a table here showing the individual values in a particular data set. And if we were to take these values here, and then we're going to make a histogram out of them, here's what we would get. So you can see a slight skewness in the distribution here. My friends in industry would say this is skewed to the left because the bulk of the data is shifted toward the left. However, a pure statistician, like the one who authored your textbook and writes your assignments, he would say, no, this is skewed to the right because you've got a larger tail in the distribution there on the right side. Either way you look at it, the data is skewed. So because of its skewness, we can't take that bag of tricks that we've got for dealing with normal distributions in our statistics toolbox. We can't use those tools. So in order to help us to use those tools, we're going to transform the data set into something that more resembles a normal distribution. To do that, we're going to apply a mathematical operation. And the one that I'm selecting here is just taking the logarithm of each value in our data set. So if we extend our table out, so we can put in the transformed values. And we start by just taking the first value there in the data set, the 6, and we're going to take the logarithm of that number. So the log of 6 is 1.7918, and that number then becomes the first value to be listed in our transformed data set. I can perform the same operation for each of the other values in the data set and finish filling out the table. Now I've got a set of transformed data. And if I take that set of transformed data and make a histogram out of it, you can see that we still got a little bit of skewness in the data, but it's much, much closer to a normal distribution than what we've seen before. And if I can go and make a normal quantile plot of this data and it confirms, yes, we've got a normal distribution, now I can take all those tricks that we've learned in the previous mini lectures about making and analyzing and interpreting normal distributions. All those tricks we can now use on this data set. This is the power and the value of data transformations. It allows us to take that bag of tricks for normal distributions and apply it to distributions that are not normal. But the key is you've got to have some sort of transformation that makes the data conform to a normal distribution. So not just any transformation will do. And you get more experience in understanding what transformations will do what on a particular data set, the more practice you get making transformations. The more experience you get with this, the more you can kind of assess beforehand, what transformation you need to make to apply to your data to get it to where you want it to be. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.